today y'all are going to learn about the different properties of triangles. So to start off, we're going to go ahead and fold this. So you're just bringing both sides into the middle, just like so. And then you're going to cut down both of these lines. So you'll have 4 flaps. Okay, so the first thing we're going to talk about is the perpendicular bisector. And if you remember, a bisector cuts something in half. So that's exactly what this will do. So specifically, a perpendicular bisector is a line segment or ray that is perpendicular to the side and passes through the midpoint. So all that means is if we have our midpoint M, now remember, to be a midpoint means it's in the middle of that side, making these 2 smaller sides congruent. And to be a perpendicular bisector, it's just going to go through a side and line, and it's going to form 2 right angles. So just like so, that's a right angle here and there. That's a perpendicular bisector. So we can go ahead and open that up. Now for every triangle, you can have 3 perpendicular bisectors, and the reason for that is because there's 3 sides to every triangle. So remember, they go through the midpoint of the other side. So if we have midpoint here, that means these 2 sides are congruent, and our perpendicular bisectors through the opposite side. So here's our perpendicular bisector right there. And then we can do one on each of the other sides. So if I have another midpoint here, these 2 are congruent. And here's my perpendicular bisector, because this is perpendicular. Then I have one more that I can draw through this midpoint, which makes these 2 sides congruent. And it just goes through the opposite side and this midpoint at a right angle. So all 3 of these perpendicular bisectors intersect at one point, and we can call this point P. So for this triangle, P is the circumcenter. So where all the perpendicular bisectors intersect is what's called the circumcenter. And the circumcenter is a point of concurrency. So we'll talk about 4 types of points of concurrency today, and the first one is the circumcenter. So a point of concurrency is just where 3 lines intersect. So where 3 lines intersect. And like I just said, for perpendicular bisectors, they intersect at what is called the circumcenter. And what we know about those is that they're equidistant from each vertex. So what that means is that if I were to go from my circumcenter to the vertex, this would be congruent to this, which is also congruent to this. So if I draw a line from the circumcenter to any vertex, those 3 lines would be congruent. Knowing that, we can solve some problems. So for this triangle, we're told that P is the circumcenter. So we have our circumcenter right here. Since P is the circumcenter, we know that all of these lines drawn at perpendicular angles from a vertex to a side, those are all perpendicular bisectors, since where they intersect, we were told, is the circumcenter. So since they're perpendicular bisectors, that means each of these sides are bisected into two congruent parts. We also know that since this is the circumcenter, from the circumcenter to each vertex is congruent. So we were able to tell all of that just from this statement right here. Now, knowing that, we need to find what EP and EK are. So if MP, this distance right here, is 4, then what is EP, this distance right here? Well, that would also be 4, since these are congruent. Now we know that ER is 3. Well, if ER is 3, then RK is also 3. And they want to know what EK is. EK is this whole length. So if both parts are 3, we would add those together and get 6 for EK. Now we can look at the angle bisector. So it's another bisector, so we know that something's going to get cut into two congruent pieces. And since this is the angle bisector, it would make sense that the angles are what get bisected into two congruent pieces. So an angle bisector is a line segment array that divides an angle into two congruent angles. And remember, congruent means that their measures will be equal. So it says it divides an angle into two congruent angles. So that could be this line right here, making these two angles congruent. That would be an angle bisector. And just like the perpendicular bisector, we can have 3 of these for every triangle because there's 3 angles in every triangle. So we could have an angle bisector right here through this top vertex. So these two angles would be congruent. We could also have one through this vertex, making these two angles congruent. And lastly, we could have one through this vertex, making these two angles congruent. Now, where the 3 angle bisectors intersect is at what's called the incenter. So if I labeled this S, then S would be the incenter for this triangle. Now the incenter is the point of concurrency for the angle bisectors. So the incenter is where the angle bisectors intersect. So you find it by finding all 3 of the angle bisectors first. Now what we know about these is that they're equidistant from each side. So what that means is that from the incenter to each side, so these 3 lines right here, these are all congruent, because equidistant means that they're the same distance. If they're the same distance, then they're all congruent. So they're equidistant from each side. Knowing that, we can solve another type of problem. So we're told that U is the incenter of the triangle. So this right here is the incenter. If that's the incenter, then all of these lines we have going through the incenter are the angle bisectors. Since they're the angle bisectors, we know that each angle is cut into 2 congruent smaller angles. So we would know that these 2 angles are congruent, these 2 angles are congruent, and these 2 angles are congruent because they're angle bisectors since they're intersecting at the incenter. Now, it wants us to find the length of MU. Well, MU is right here. Well, how can we find that? Well, since this is the incenter, we know that it's equidistant from each side, so these 3 segments would all be congruent. So if UP is 5, MU is also 5. Then it wants us to find angle PHU. So angle PHU is that angle formed right here. And we know since these are angle bisectors, that these two angles are congruent. So if this one's 21 degrees, then this one is also 21 degrees. So the angle PHU is 21 degrees. Now we can talk about the median. So median has to do with being in the middle. So a median is a line segment that connects the vertex of a triangle to the midpoint of the opposite side. And remember, the midpoint is in the middle of that side. So when you think of median, think middle. So in order to have the median, we have to have that midpoint of one of the sides first. And if it's a midpoint, we know that it's cut into two congruent sides. So these two sides are now congruent. And it says that it's just the vertex to the midpoint. So I'm going to draw exactly that, from the vertex to the midpoint. It's not necessarily going to be at a right angle. That would be perpendicular bisector. But it's just from a vertex to the midpoint, wherever that is. And just like perpendicular and angle bisectors, there can be 3 of these in every triangle, because there's 3 vertexes and 3 midpoints in every triangle. So if I have a midpoint here, I can have my median from this vertex to this midpoint. And if that's a midpoint, I know that these two are congruent. I can also have one at this midpoint. So I'd connect the opposite vertex to that midpoint. These two sides would be congruent. And then I can do it through this midpoint right here to the opposite vertex. And I would know that these two sides are congruent. Now the median's intersection point is called the centroid. So they intersect right here at point A. So A is the centroid here. And the centroid is the point of concurrency for the medians. So the medians intersect at what is called the centroid. Now what we know about the centroid is a little different than perpendicular and angle bisectors. We don't necessarily know that anything is congruent. Instead, we know that the centroid is 2/3 the distance from each vertex to the midpoint of the opposite side. So if we're starting at the centroid and going to the vertex, starting here, going to the vertex, we know that this is 2/3 of this total distance. So it's 2/3 the distance of the total median. So if this part is 2/3, then that leaves this to be 1/3. So from the centroid to the opposite side is 1/3 the total distance of the median. So it seems a little confusing, but we can use that to solve some problems. So if we look over here, oops, there we go. We know that U is the centroid. So that means that all of these are medians. So if they are medians, then we know that they all intersect at midpoints. So we have a lot of congruent pieces. We know that these two sides are congruent, these two are congruent, and these two are congruent, since they're medians, and medians go through the midpoint of each side. So it wants us to find the length of CU. Well, CU is this distance right here, from the vertex to the centroid. And we know that that distance is 2/3 the total distance. Well, we also know that UK is 12. And from the centroid to the opposite side, we know is 1/3 the total distance. So if 1/3 the total distance is 12, then 2/3 would be 2 of those. So 12 plus 12, which is 24. So if we know what the 1/3 distance is, we can find the 2/3 distance. Well, we can do the opposite of that as well. If we know the 2/3 distance, we can find the 1/3 distance. So let's do that. It wants us to find JU. JU is from the centroid to the opposite side, so we know that that's the 1/3 distance. Well, the 2/3 distance, UD, is 9. So if 2/3 is 9, how do we get 1/3? Well, that would be half of that. So 9 divided by 2 is 4/5. I'm sorry, 4.5, not 4/5. It's 4.5. So if we know the 1/3 distance, we can find the 2/3 distance. Or if we know the 2/3 distance, we can find the 1/3 distance. Now it wants to know what's congruent to JE. Well, JE is this side right here. We know it's congruent to this side, CJ. And that's because the medians go through the midpoint, and the midpoint bisects the segment into two congruent pieces. Now, lastly, we can talk about the altitude of a triangle. And some of you may have heard of an altitude before, but a lot of you have just heard of an altitude as the height. And that's all it is. Altitude and height are basically the same thing. So the altitude is a line segment through a vertex that is perpendicular to the opposite side of the triangle. So to be an altitude or height, you have to be perpendicular to that opposite side. You start at a vertex and go to where you're perpendicular to that opposite side. So if we were to start at this vertex right here, there would be our altitude or our height because it's perpendicular to the opposite side right here. So this length would be our height of the triangle. Just like the bisectors and medians, we can have 3 altitudes for every triangle because there are 3 vertices and 3 sides of every triangle. So it says we go from the vertex to the opposite side in a perpendicular way. So if we started here, there would be our altitude. Or we could go through this vertex to here. Here would be our altitude because remember it goes to that side perpendicularly. And then we can go to this one. So those are all 3, the altitudes or the heights of the triangle. And where all 3 of those intersect is at the orthocenter. So if we labeled that Q, then Q would be the orthocenter for this triangle. And the orthocenter is the point of concurrency for the altitudes. So where this gets a little tricky is when we have an obtuse triangle. When we have an obtuse triangle, all of the heights or all of the altitudes aren't necessarily found inside the triangle like they were here. So it says to construct the 3 altitudes of the triangle. So we know this is an obtuse triangle because this angle right here is obtuse. So going from the obtuse angle to the opposite side perpendicularly, there's 1 height, and that's the easy height to find here. Now the question is, how do we find the other 2? If I were to go to this vertex to this side, there's no way I could draw this to where it would intersect this side at a right angle. So what I have to do is actually extend this side length right here. So I'm going to keep going with this side length. Now I can draw a perpendicular line from this vertex to here. So this right here is another altitude or height of this triangle. So when you have an obtuse triangle, 2 of the altitudes can be outside of the triangle. Notice it's not on the inside. Now we're going to do the same thing for this vertex. Notice we can't draw a perpendicular line anywhere to this side, so we have to extend this side. If we extend it, then we can draw our altitude right here because that's where it's perpendicular to that side. Now, if we have our three altitudes, we're told that the three altitudes intersect at what's called the orthocenter. But do you see these three altitudes intersecting? Because I don't. So what we have to do is actually extend the three altitudes to see where they're going to intersect. So I've got to extend all three of them. My drawing is a little off. So they all intersect at about, oops, right there. So my orthocenter is actually outside the triangle. So over here for my acute triangle it was inside, but when I have an obtuse triangle, the orthocenter is going to be outside the triangle. So the orthocenter of an obtuse triangle is outside the triangle. And in order to see that, you have to extend the two sides, and then you had to extend the altitudes or the heights. Now we can go ahead and glue this into our notebook on the next page. And title it Bisectors, Medians, and Altitudes of Triangles. There we go. So we can go ahead and glue this in. Just like so. Oh, and I forgot to show you before you glue that in, you needed to make a new pocket right before that, titled Chapter 5, Relationships in Triangles. Then you can go ahead and glue that right behind it because we did just test, so we need to start a new pocket. And once you do that, you can get your foldable glued in.